Hello. Welcome back. I got a lot of questions about this exercise, so I want to try to solve it very fast for you. Here, let's dive in. Konrad Weitzel produced four different models of water pumps as shown in the figure below. The operation manager knows that the total monthly demand exceeds the capacity available for production. That means we have a bottleneck. True, she is interested in determining the product mix which will maximize profits. That means how many products of each one, since we don't have time to build all of them, gonna make the more money for her. Each model price, routing, processing time, material costs are provided in the figure. Demands for the next month is expected to be 200 units of Model Alpha, 350 units of Model Beta, 150 units of Model Gamma, and 225 units of Model Delta. The company operates only on 8-hour shifts per day and is scheduled to work for 20 days the next month with no overtime. So we know that 8 times 20, that's the total time we have in hours. Okay, good. Let's keep that for now. Further, each state requires a 15% capacity cushion. What does that mean? That means that we need 15% of the time to be available, that are time for people to go to the bathroom, to set up between different manufacturing models, and so on. So we cannot use this 15% of the total time. So what we do, we get the total time and we reduce 15%. Okay? Which station is the bottleneck? Well, to do that, first thing we need to do is find how much time we have. So we have 8 times 20 days times, let's change everything to minutes. And I'm going to explain that in a second. That's going to give us 9,600 minutes. Why do we have that? Well, we are working minutes down here. So let's convert everything to minutes, make our life easier. Okay? Then we need to understand how much time we actually have available. Well, I said to remove that 15%, so we can do 9,600, 1 minus 0.15, that's 9,600 times 0.85, that gives us 8,160 minutes. That's our available time. So any station that works more than 8,160 minutes gonna be a bottleneck. Okay? With me so far? Good. So let's try to figure out each one of the 4 stations have more time than that, need more than 8,160 minutes. Well, to do that, now we come to this table. And what we're gonna do is find out the total time that we're gonna need to be able to produce the amount of products we need. Okay, so we have here in the left side how many units we're producing, and we have the time per unit. So we just multiply them, and what we're gonna find is that station A gonna need 2,000 minutes, 0 minutes, 5 times 150 gonna be 750, and 4,500. Okay, so what I did here is just multiply the demand with the time we need for 1 unit, and I'm gonna do this for all of them. So I'm gonna have 1,000, 1,000, 5,000, 2,250, and 1,125, and for efficiency I have 1,000, I have 1,500, 750, 2,250, and finally I have 2,000, 0, 3,000, and 2,250. Now I can add those numbers now, and then what I'm gonna end up having is 250, 9375, 8500, and 7250. Okay, those are my times. Which one of those are greater than what we found before? 8160. Well, in this case, we have this one here and this one here. Okay, so the stations B and C are bottlenecks. The second question asks for the optimal mix of products that we can have and overall profitability or profit that we can have using this mix of products. Using the traditional method, and then later we're going to use the bottleneck method, okay? So since we have 2 bottlenecks, it's going to be a little bit different, but the logic behind it is the same. So what we need to find out is how many alpha, beta, gamma, in delta, how many units of each one of those, and the profit. That's the same thing we need to have for question C. The first thing we need to do is to figure out our margin. Our revenue minus cost, it's equal our margin. How do we solve that? We just build a table with our revenues for each one of the products, alpha, beta, gamma, and delta, with those costs. Okay, where does the number come from? Well, the first one will come from here. We have the price, okay, and the second one will come from our raw material. Based on those numbers, we know that the order we're gonna have to solve is this, this, and this. This is our priority, okay? So we're gonna start with beta, that's greater than alpha, that's greater than delta, that's greater than gamma. How do I find how many units I make of each one of those? The first thing, stations that are not the bottleneck means that I can do whatever quantity I need of the ones that we calculated in letter A. Okay, I don't have bottlenecks, so I can make the units they are demanding. The ones I do have bottlenecks, those will limit our ability to make more units. Okay, so to do that, what I'm gonna start doing is looking at station beta, that's our first one, and how much time do I need there? Well, we found here, right? It's 1000, 5000, 225, 1125 for station A, B, C. Okay, I know that this and this are not bottlenecks. All the stations gonna start with 8160 minutes available. The first product gonna build is beta, and we'll need 5000 minutes of station B and 250,000 minutes of workstation C. So for 200 units, I'm gonna need of beta. For workstation B, I'm gonna need 0. Here, I'm gonna need minus 5000, minus 250, 100, and 0. Okay, doing this calculation, I have remaining 8160, 3160, 5660, and 8160. Then I'm gonna do for 200 units of alpha. I'm gonna need 2000, 1000, 3000, 2000. Okay, so I have remaining 6160, 2160, 2660, 6160. Okay, next I have 225 units of delta. And I'm gonna keep going. So it's minus 4500, minus 1125, minus 2250, minus 2250. And then remaining I have 1660, 1035, 410, and 3910. Now I need to know what's left to make gamma. Let's start here. For gamma, I would need 750 this, 2250, 750, and 3000. Look at those numbers and compare what we have left. This works, and this one works. But what about those here? They will not fit. So I cannot make all of those units. So what I can do is divide by the time needed for each one of those. In this case, this one I can divide by 15, and this one I can divide by 5. And what I'm gonna find is this one will be 69, and this one be 82. This here is limiting my production of gamma at 69 units. What I do with the 69? Well, that's how many I can do of gamma. So we can come back here, say gamma is 69, and all the others are exactly as we predict. 100, 250, 225. The total profit, it's our margin that we calculated, times the number of units we're gonna be making. 200 times 70 plus 250 times 85 plus 69 times 60 plus 225 times 65. And this total should be 54,015. That's our answer.